Hello, this is Asad Khatanani. I'm a mechanical engineering student in Just University. Today, me and my team members are going to talk about an efficient DC motor design. I'm going to handle a brief explanation on how DC motors work and speak about the motor losses and eventually talk about the chosen DC motor design that we have chosen as an efficient design, which is the Maxon's motor.
Ladies and gentlemen, my name is Layth Talib. I'm a mechanical engineering student at Just University. Today I'm going to speak with you a little bit about the efficiency, and I'm going to go deeper into the efficiency and about how it works and what is the meaning of efficiency, and about some technologies that we can use it to make the efficiency better and more maybe less costing to us. And I will talk a little bit also, take some part about the Maxon motors DC to explain a little bit about it.
And you will have me with you, Mohammed Samir Al-Aqbawi, studying mechanical engineering at Just University. I will talk about the introduction and I will talk about the history of electrical motors, and also I will be part of talking about the losses that electrical motors have, and also I will talk about the technology that we can use to increase the efficiency, and also I will be part to explaining the Maxon efficiency and how it works.
And for today's topic, we're gonna talk about something quite important, which is an efficient design for DC motors. And before we even get into it, we need to talk about something way important, which is the definition of the efficiency and also the losses that are related to it and how we can reduce it. So in this engineering world, the mechanical energy is very important for our life, and the scientists did a lot of job to see a lot of methods to get into the mechanical energy through heat pumps, combustion engine, and also electric motors. And as we said in this project, we're gonna talk about the DC motors and how they work, and most importantly, how to make them more efficient, and discuss the evolution of electric motors. So right now we're gonna talk about the history of electric motors, and the first prototype was invented in 1740s. It was invented by two scientists, which is Scottish Bentington and the science Andrew Gordon, and other science also, which is Michael Faraday and Joseph Henry. And they did continue to develop early electric motors and experimenting with electromagnetic fields and discovering how to convert electrical energy into mechanical energy. And in the year 1834, it was the first electric motor was invented by Thomas Davenport. And by the way, it was powered by a battery. And the year 1886 was the year the first DC motor was invented in, and they performed heavy-duty tasks on a larger scale.
As we know here, usually magnets attract or repel in nature. So if we insert a conductor in a magnetic field, this is going to be called an armature. We're going to connect the conductor to a battery to make some current flow. The current inside the conductor will form a magnetic field. And now we have two magnets, and those magnets are going to want to attract, as known as forming a force. The commutator is a mechanical rectifier that will keep the current flow in the same direction. A single conductor has two poles. So if we add more than one conductor, we're gonna need more poles, 4, 6, 8. Adding more conductors is gonna be in our advantage.
So we're gonna start talking a little bit about the definition of efficiency and what it does and how it works. So efficiency is a measure of how much total energy a motor uses in relation to the rated power delivered to the shaft. Like an example, electric motors are simply devices that convert electrical energy into mechanical energy. Like all electromechanical equipment, motors consume some extra energy in order to make the conversion. As we can see here, efficiency is the output power we get divided by the input power we invested in the motor. In real life, we know that there is no 100% efficiency motor that works. And why is that? All types of engine experience some sort of losses. Those losses will consume a sum of energy that we invested in the machine and will not be beneficial for us. And from the second law of the thermodynamics, we understand that losses occur due to the irreversibility.
Motor losses. 70% to 95% of the electrical energy absorbed by the motor is converted into mechanical energy, the energy that we desire and we really want. As my colleague Laith has explained the meaning of efficiency, this is the efficiency value of the motor, which is an important technical indicator of the motor. So the remaining 5% to 30% is actually the part that the motor will consume and the losses do the heat generation, mechanical loss, and this part is the electric energy that is wasted. If we can make a way to reduce those losses, the motor will obviously be more efficient. Number one, electrical losses. Armature resistance. High resistance leads to increased power losses and reduced efficiency. So what's the solution? Minimizing armature resistance through the use of quality conductors and appropriate wire gauge improves the motor efficiency. Field winding resistance. Higher resistances affect the field current and reduces motor performance. So the solution is using low resistance field windings and optimizing winding designs helps improve motor efficiency.
So along electrical losses, it will be brush contact resistance. A poor brush contact, it will increase your power losses and also it will destroy your motor efficiency. So what is the solution for that? What is the solution that it will help you? Well, first of all, regular inspection and a good maintenance of the brushes, so you will take care of it. And also you need to use a high quality of brushes. If you did all of that, that would really help you to reduce the contact resistance.
Number two, mechanical factors. Friction and bearing losses. High friction and bearing losses increase power consumption and reduce efficiency. So what's the solution to increase the efficiency? Proper lubrication and maintenance of bearings along with use of low friction materials will minimize these losses and enhance the motor's efficiency. Number three, thermal factors. Temperature rise. Excessive heat can reduce motor efficiency and potentially damage insulation. So what's the solution? Implementing efficient cooling mechanisms such as fan cooling or liquid cooling and keeping an eye on motor temperature ensure optimal performance and efficiency. Insulation quality. Poor insulation can result in increased heat generation and reduced efficiency. So we can fix that using high quality insulation materials and regularly inspecting and replacing damaged insulations. This will prevent energy losses and maintain motor efficiency.
As my fellow colleague said, Asad, electric motors technology has undergone significant advancement over the past decade, offering increased efficiency, compact design, and enhanced performance. For example, to increase the efficiency, we can use the robust construction and durability. High-quality DC motors are built to withstand the harsh operating conditions of steel plants. They are designed with the robust construction, superior insulation, and effective cooling mechanism. But how this robust construction and durability works exactly? It ensures that the motors can handle high temperature, heavy loads, and continuous operation without compressing performance or efficiency. Another thing we can maybe use, it's the continued integration. Electric motors will be connected to the Internet of Things. But why do we use it? Why do we use it, and how it works with us to increase the efficiency? Because its connectivity will enable real-time data, monitoring predictive maintenance, and remote control, optimizing the efficiency and reducing the downtime.
So just like my teammate Laith, they talk about a lot of things to help you to increase your efficiency for your electrical motor. I'm going to talk about something quite interesting, which is advancement in magnet technology, which is the way that we invent new magnet materials, such as a real earth-free magnet. We don't really go for a natural thing. We go for something that we develop, we made it. That real earth-free magnet will reduce the reliance on critical resources, and also it will be more sustainable for an electrical motor design.
So, after we spoke about electric motors, explained their working principle, and defined efficiency, and spoke about the advancements, we would like to talk about the conclusion, how knowing all this information will help us to be creative and achieve a unique design. So, scientists took all these points in consideration and designed the Maxen's motor. But the real question is, what makes this motor so different? The key to high efficiency for Maxen lies in the fact that they have no iron losses. Maxen manufactures ironless core or coreless motors designed to the needs of their customers. This means that the losses associated with the iron components have been eliminated. By designing coreless and ironless core motors, Maxen also eliminated the largest concentration of stray losses associated with the motors, which are also associated which are losses associated with the leakage in the laminate core.
So as we know, normal DC motors have the efficiency relative close to 16%, and this is due to the fact of it has some losses. Like one of the main losses is core losses. Core losses consume a lot of energy, which will decrease the efficiency. But core losses can be divided into too many parts. So we will take two examples. For example, like eddy losses. And what do we mean by eddy losses? Basically, even if it was reduced, it's still not eliminated. And also, eddy is known as the iron losses. To decrease eddy losses, we can use lamination. Basically, each lamination is inserted from the other by a thin layer of coating, varnish or oxide film. And the other part, for example, stray losses that always come with the cost of using a magnetic core. And another thing, for example, like hysteresis losses, which is similar to eddy losses, but it occurs in the armature winding due to the reversible of magnetization of the core.
So yes, we have a problem right here. We have like the normal motor, the normal electrical motor, which is its efficiency goes around between, you're talking about 50 to 60% only, which is a huge problem. So scientists thought about fixing this problem, and they did something quite interesting, which is they eliminate the core from the electrical motor, and that's exactly what they just invent. They invent the Maxen motor, and the Maxen motor, it gives you over 90% for the efficiency for the electrical motor. And if you want to compare it, you will see that the Maxen motor, it give you high performance, but the normal one, which is give you from 50 to 60% only in the efficiency, it doesn't give you that good of a performance.
So knowing how the motor works, understanding each component and its goal in the motor will help us achieve more efficient and creative designs. And that is one of the main points of making a smart engineer. Engineers make the life we live easier, and this world is facing rapid changes, and new technologies are being invented, new materials are being discovered. And these all will help us live in a more efficient world with more efficient motors. And hopefully one day we will reach the efficiency percentage of 99.9%.